Welcome to a new video. Last class we discussed about the insertion in linked list. Today also I am continuing the same session. Here we have three cases of insertion. First one insertion at the beginning, second one insertion at the end, third one insertion in between two elements. Okay. Last class we discussed insertion at the beginning. Anyhow, I just want to discuss the programming part of this one also. Verifying first step is to verify the list is empty. List is in the empty in the sense head equal to null, because head always represents the first element, like the engine of a train. If the head is null, what's the meaning of that? We can say that the list is empty. Okay, head is a pointer. Head represents the address of the first element or the first node. Okay, so if a head equal to null, then we need to create a new node and make the new node as a head node. So the procedure is verify whether if head equal to null. If head equal to null, we can say that the list is empty. If the list is empty, what we are going to do is we will create a new node by using a memory allocation function, dynamic memory allocation function. P is a variable, a new variable that I am dedicatedly used for creating new nodes. Okay, so the syntax for malloc function is to malloc, then size of is a function that you may already studied. Size of is a function to find the size of a particular variable. Size of struct node. So this is a syntax of memory allocation, dynamic memory allocation. So after executing this particular statement, a new node will be created with two partitions. So how these two partitions are created is, we already discussed syntax of a structure. We are using structure, struct, structure to define the particular node. So consider this is the structure that I am going to create. Struct node. Okay, node is the name of the structure, and inside that braces I am going to define the member variables. Here, which one are the member variables? Here we have two partitions. One is the data partition. So I am declaring the data member here int data. Okay, the second one is what? The address of the next variable. So address of the next variable in the sense, consider in this case 70 is the data and 100 is the address, and 100 represents the address of the next element. So this 100, again, it has the property of a same node. So what's the meaning of this? We are going to refer the same structure. That is why I explained about the self-referential structure. So this partition refer to the same structure, same node having the same property. That is the meaning. 100 is the address, and this 100 having another node. 100 represents another node, and this node having two partitions. One is the data partition, another one is the address partition. So it's a self-referential structure. We are referring to the same structure itself. So a variable name struct node star next. So the next is a variable which refer to the same structure itself. So that is a self-referential structure. So this is the structure of a node. Okay. Then I am using two more variables. One is head, which equal to head, and then star p. P is a variable for creating a new node, and q for traversing. So this is a programming way. This is one of the way of writing the program. Like I am using p variable for creating new node and q for traversal. Traversal in the sense moving from one node to another, that I will discuss. Okay. In this case, insertion at the beginning. Here the first step is to verify whether the list is empty. In this case, head equal to null. If head equal to null, we can say that the list is empty. If the list is empty, then the new node that we are going to create will be the first node. So first step is to create a new node. how to create a new node? I am using a variable p for creating the new nodes. So p equal to malloc size of struct node. So what's the meaning of this? I will explain. Malloc is a function, is an inbuilt function to create a memory whenever it is required, and for creating the memory, what we need the size, how much memory we need to create. So how to find the size? So here this is a, consider here we know a node having two partitions. One is address partition, it's a referential part, so we don't need any address here, size here, but this is a integer part, so integer we need the size. So totally we need 2 bytes. So this is actually the final thing that this malloc function is going to pass as a parameter. So malloc of 2, malloc of 2 in the sense this 2 comes from the particular node's size. So from how can we do this one automatically? We can directly give it as 2, but we can't expect that all the cases the node structure will be like this. Sometimes we will add data, two data, for example name, student details. So name is one data, register number is another data, mark is another data. So it should be dynamically created. For that I am assigning another I am using another function, that is size of. Size of is a function to used to identify the size of a particular variable. So in this case, a node having a common structure. So this node will give, the size of the node will give the exact size of a particular node. So that is why we are using this syntax here. So what's happening here is, this size of struct node will return a value 2, and that 2 will considered as a parameter of a function malloc. So that is the way where a node is created, and that address of that particular node, a new node, will be saved in the variable p. Consider I created a new node like this, and the address will be saved in the variable p. So p equal to 500. So this is the way that we created. Once the new node is created, what's the next step? If the list is empty, I am discussing about if the list is empty. If the list is empty, then we can mention it as head, because the newly created node is the first node, so we have to mention the new node as a head node. So head equal to p. So insertion at the beginning, if the list is empty, that we discussed. If head equal to null, verify whether the list is empty. If the list is empty, that what is the meaning of that? The newly created node will be the first node, and that node will be represented by the variable head. For that I created I used malloc functions for dynamically allocating the memory. So malloc size of struct node, and p equal to, and p, so p is consider the address that created for this particular node is 500, and that is saved in the variable p. And once a node is created, and what's the next step? Once a node is created, here we have to assign the value p tends to data. Two partitions are there. The first partition is p tends to data equal to 70. So after that 70 is added into that data partition, and then p tends to next. So what is the meaning of this? P tends to next. So this is the first element that we are creating, that is a new node, and this is the only node that we are having. There is no further elements available after this node. So what's the meaning of this? This part should be null. So p tends to next equal to null. So null. So one node is created. This is the way that we created if the list is empty. If the list is empty. If the list is not empty. So already we have one node. Consider we created one node, and this node is represented by the variable head. Head is having the address 500. Consider I am going to create a new node. Again, in the beginning of the node. That means before 70, I am going to add a new node. So what is the procedure? First step is to verify if the queue is empty. If the, sorry, not queue, the list is empty. If the list is empty, then we can follow the same procedure. If the list is not empty, then we will move to the second step. List is not empty. Second step, create a new node. Okay, again the same statement I am using here. List is not empty. Anyway, we are going to create a new node. There is no doubt on that, because here we don't have a case of list is full or not, because we are dynamically allocating the memory. The memory, whenever you need a node to create a node, you can create a memory. So there is no limitations of memory. Okay, so anyway, we are going to create a new node. So first step is to create a new node, and consider I created a new node, and that new node, for example, the address is 400. So P also having the address 400. Okay. After that, what's the next step? This is going to be the first node. Okay. What's the meaning of that? And once this node is going to be the first node, then the address field of this particular node should contain the address of the previously headed node. That means the first already existing head node. So what I am doing is, first step is to assign the value p tends to next equal to 80. So assign the value 80 here. Okay. Then address part, we have to fill the address. Sorry. I made a mistake here. P tends to data equal to 80. Okay. Then P tends to next. That is address part. Address part should be filled with what? That should be filled with the head node, because head is the already existing first node. So I am assigning head. So initially, what's the value of head? Head equal to 500, and that 500 is assigned here. Okay. So now a node is created like this. A node is created and it is represented like this. Okay. A link is created by a link is created like this. Okay. Now this is a way that we are creating a new node, and after this statement, what is the next statement? The newly created node is assigned as the head node. So head equal to P. So what will be the value of head? Head equal to 400. Clear? Next, insertion at the end. That is the next process that we are going to discuss here. Insertion at the end. So consider here these are the list of elements. We are going to insert the element after 50. So first step is to travel from head node to the last node, because we are having only the link like head. So we have the first element's address with us, and from this address to we have to move on to 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Once we reach here, then we can perform the insertion operation. The first step is to travel from head to last node. How will we travel? So I am using a variable q. So this is said to be traversal, that I already discussed. So q equal to head. I assigned the variable q equal to head. Okay, q is assigned the variable head with the variable head. So what is the value of a q now? Q equal to 100. And what's the next step? How will we identify whether the node, we have to travel. First step is we are in this, now q is in 10. Q represents the value 10. So next step is to verify whether this is the last element. we don't know whether this is the last element or whether the next one is the last element, the next one is the last element. So first step is to identify whether Q is residing on the last element. If Q is residing in the last element, then we don't have any issue, we can directly insert, otherwise we have to travel. So how will we verify? Verify by checking this with Q tends to next not equal to null. If Q verify that while in the sense we have to continuously do the same process until we reach to the last element. So for that I am using the while loop. While Q tends to next, Q equal to what? 100. 100 tends to next is what? 200. 200 not equal to null, condition true. If so, we can confirm that Q is not representing the last element. So the next step is we have to travel from that element to the next element. Q equal to Q tends to next. Okay. Now consider we are starting from the beginning. 100 tends to next, that is 200. 200 not equal to null, condition true. If the condition is true, then we are assigning the value of Q to Q tends to next. So Q is reassigned as Q tends to next. Q tends to next. Already existing Q tends to next is what? 200. It's 200. Then again 200 tends to next. 200 tends to next is what? 300. 300 not equal to null, condition true. Then it moves to the inner statement, Q equal to Q tends to next. So Q equal to Q tends to next, 200 tends to next. What is that? Q equal to 200 tends to next, 300. Again 300 tends to next. 300 tends to next is what? 400. 400 not equal to null, condition true. Q equal to Q tends to next. Then Q equal to 400 tends to next. Q equal to 400 tends to next, 500. Then 500 tends to next not equal to null. What is that 500? 500 tends to next is what? Null. Null not equal to null, condition false. What's the meaning of this? We reached, or a Q reached the last element. So now Q is in the last position. Okay, once we reach the last position, then we can easily perform the insertion operation. What's the next step? Create a new node. Very simple. To create a new node, what we are doing is P equal to malloc. Remember, this is a standard syntax. Malloc size of struct node. Okay. What's the meaning of that? A new node is created. Consider P's address is, for example, 600. Okay, 600. Next, a new node is created. Consider for representation, I am using the same picture here. Okay, consider this is the case. Okay, new node is 600, and this is empty. This is also empty. So we can confirm that the address field of the newly created node will be null, because that is going to be the last element. So P tends to next. Without any doubt, we can directly add like this. Without any confusions or anything, we can directly say that the last element's address field should be null. That is a property of a single linked list. So this is null. No doubt on this. Next step is we are going to create a data here. Data equal to, for example, 90. So element, that is 90. Okay, the field, that node is filled with all the necessary details. What is next? The previously previously available last element, that is 50's address, we should be replaced with 600. How will we do that? Now 50 is represented by the variable Q. So Q tends to next. Q tends to next equal to what? The newly created node. The newly created node's address is available with the P. So P, very simple. Insertion at the last also completed. Okay. So now I am stopping here. If you have any doubt, please call me. we will discuss in the Google Meet also. Thank you.